Hello everyone, I'm Siamul Karim. I'm presenting DeformIrisNet, an identity preserving model of tire texture deformation. I'm a PhD student at the University of Notre Dame. So, one of the main problems with using iris as a biometric trait for recognition is that the iris texture changes quite drastically when the pupil size changes due to changes in illumination. There has been research to show that this degrades iris recognition performance. So, the classical approach is usually assumes like a linear deformation model, or for nonlinear models, they assume certain properties about the iris musculature, and we believe that is not enough. So, we propose an end to end deep learning based model for this. Here we discuss about the architecture and the losses. So we utilize a modified unit architecture for our autoencoder, but it's more important to see the losses that we use. So we have a mask loss that optimizes the logics from lightweight segmentation model. We have an identity preserving loss that uses iris domain specific human source filters that were learned from human salivary regions. These filters can capture the iris texture conforming to different identities and help the model learn the authentic iris muscle movements. We have the L1 loss that maximizes general similarity, and we have the perceptual loss that maximizes the perceptual similarity between these two images. To be specific, we utilize the learned perceptual image path similarity LPIPs. Here we have some sample outputs of our network. So for the first image, we have different masks with different pupil sizes, and the a single input iris image, and the outputs show the different deformations. And in the bottom figure, we have the target. We have a fixed mask and different iris input images with different pupil sizes, and the bottom shows the output. So both of these figures are of the same identity. So we can see that when the pupil size variation is very large, we get a more blurrier texture, showing that the network has a harder time when the pupil size change is very large. But if we compare the different images, for example, if we compare the bottom row of the first image and the first row of the second image, we can see that the even though the texture might get blurrier, it still preserves a lot of the textures that are important in the identification, and we do see similarities between these images. So here we compare our model in terms of its iris recognition performance. So we use the decidability score, which assumes that the genuine and imposter distributions are Gaussian distributions and measures the distance between these distributions, equal error rates, and the ROC curve. So we find that the in terms of decidability scores and the area under the curve, our model performs better than the the linear and the biomechanical deformation model. But in terms of equal error rate, the results are not that apparent. So here we discuss about the potential applications and side effects our model has. So firstly, we believe it can greatly help the human examiners, since comparing iris images with large difference in pupil size is very tough for them, and our model can actually provide them with images of the same pupil size. We also see that our model can remove noise from the input image, though we should mention that we didn't explicitly train for it, and if it was trained for it, it would perform even better. We can also see that our model can actually dream up iris texture when we open the eye using the appropriate mask as input. But we should also mention that this is not really useful, as the dreamed up texture would not conform to the identity. So, as a conclusion, what we do is we provide an end-to-end deep learning model that can better capture the complex iris texture deformations than the classical models that make assumptions. We demonstrate the usefulness of such model in terms of iris recognition. We support that it can be very useful in forensic human examination, since matching iris images would be easier if they are of the same pupil size. But we do indicate that we have not exactly measured how effective this would be. Thank you.